Welcome to this comprehensive guide on creating custom Unity editor tools designed to significantly boost your productivity within the Unity development environment. These tools are essential for any serious Unity developer looking to optimize their workflow and gain a competitive edge. Custom tools streamline repetitive tasks, simplify complex workflows, and provide intuitive interfaces directly within the Unity editor, making your development process significantly more efficient. By automating common actions, you can save valuable time and reduce the potential for human error. These tools are invaluable for a wide range of tasks, such as precisely adjusting game object properties, efficiently managing assets, and debugging your projects more effectively. They allow you to tailor the Unity editor to your specific project needs and personal preferences. To begin our journey, we'll first set up our Unity project and then create a new C# script. This script will serve as the fundamental building block for our custom editor window, providing the necessary code structure. Once the script is created, open it in Visual Studio. The very first step is to include the Unity editor namespace, which is crucial as it provides access to all the editor-specific functionalities we'll need. Our custom editor window will inherit directly from editor window. This base class is fundamental, as it provides the necessary framework and core functionalities for creating a standalone, dockable window within the Unity editor interface. Next, we'll define a static method that will be responsible for opening our custom window. This method is particularly important because it will be accessible directly from the Unity editor's main menu bar, making our tool easily discoverable. Inside our show window method, we'll utilize getWindow to either create a new instance of our window or retrieve an existing one if it's already open. Following this, we'll call show to display the window to the user. After saving the script, return to the Unity editor. You should now observe a new menu item, My Custom Window, appearing under the window menu. This indicates our menu integration was successful. Clicking this newly added menu item will open your new custom editor window. At this stage, it will appear empty, but its presence confirms that our basic setup and integration into the Unity editor are correct and functional. Now, let's proceed to add some actual content to our window. We'll achieve this by implementing the onGUI method, which is a special Unity method called multiple times per frame to draw and handle all GUI events within the editor window. Within the onGUI method, we can leverage the editor GUI layout class to easily create various standard UI elements. These include interactive components like labels for displaying text, buttons for triggering actions, and text fields for user input. Save your script and switch back to Unity. Reopen your custom window, and you will now clearly see the Hello Custom Editor label prominently displayed. This confirms that our UI element is correctly rendered. Let's enhance our window by adding an input field, allowing users to enter and modify text. To store this input, we'll declare a private string variable at the class level, which will hold the current value of the text field. The editor GUI layout text field method is designed to take a label and the current value of the text field as arguments. Crucially, it returns the updated value, which is how we effectively capture and process user input from the field. Now, let's implement a functional button within our custom editor window. When this button is clicked, it will perform a specific action, such as logging the text entered into our input field directly to the Unity console. The GUI layout button method is used to create the button itself, and its return value, a Boolean, indicates whether the button was pressed. We then use debug log to output the entered text to the console for verification. A very common and powerful use case for editor tools is the ability to modify selected game objects directly within the scene. We can easily access the currently selected objects using selection active game object. Let's create a new button that will change the color of a selected game object. Before attempting any modification, we'll need to implement a check to ensure an object is actually selected and that it possesses a renderer component. Inside this conditional block, we can safely retrieve the renderer component from the selected object and then directly modify its material's color property. For instance, we can set it to a vibrant red color. Back in Unity, select any game object in your scene, then open your custom editor window and click the New Change Color button. Observe the immediate visual change in the scene view. This powerful demonstration clearly illustrates how custom tools can directly interact with and modify elements within your scene, providing incredibly powerful and immediate in-editor functionality that enhances your workflow. For more complex operations, you might want to save and load data persistently. Editor Prefs is a convenient utility for storing simple key-value pairs, ideal for user preferences or small settings that need to persist between Unity sessions. For robust asset management, you have the flexibility to create custom asset importers, allowing Unity to handle unique file types or programmatically modify existing assets using the Asset Database class, offering deep control over your project's resources. Consider utilizing scriptable objects for storing larger, more complex data structures that need to persist as assets directly within your project. This approach provides a structured and efficient way to manage game data independent of game objects. When designing and creating custom tools, always prioritize the user experience. Intuitive layouts, clear labels, and logical organization make tools significantly more effective and enjoyable to use, reducing friction for developers. To achieve a clean and organized UI layout, utilize Editor GUI Layout Begin Vertical and Editor GUI Layout Begin Horizontal. These methods allow you to group and arrange your UI elements neatly, creating a structured and readable interface. For more advanced and custom UI, you can explore IMGUI for direct, immediate mode control over drawing, or delve into UI Toolkit for a more modern, declarative, and scalable approach to building complex editor interfaces. Remember to always use undo record object before making any changes to game objects or assets if you want those modifications to be undoable by the user. This is a critical step for creating user-friendly and robust editor tools. Implementing undo record object ensures that developers can easily revert any accidental modifications made by your custom tools, significantly improving workflow safety and providing a crucial layer of protection against unintended changes. For effectively debugging your editor tools, you can attach Visual Studio directly to the Unity editor process. This powerful capability allows you to set breakpoints, step through your code, and inspect variables in real time. Set a breakpoint within your own GUI method or any other editor script method where you suspect an issue. Then, trigger the corresponding action in Unity, and Visual Studio will automatically pause execution at your breakpoint, allowing for detailed inspection. This debugging technique is absolutely crucial for understanding the precise behavior of your editor scripts and for efficiently troubleshooting any issues or unexpected behaviors that may arise during development, saving you significant time and effort. Remember to organize all your editor scripts within a dedicated editor folder in your Unity project. This is a standard practice that ensures these scripts are only compiled when the Unity editor is running, not in your final game build. This crucial practice prevents editor-only code from being inadvertently included in your final game build, which in turn optimizes performance, significantly reduces the build size, and avoids potential runtime errors in your deployed application. Custom Unity editor tools are incredibly powerful assets for any developer. They empower you to tailor Unity precisely to your specific project needs and personal preferences, ultimately saving significant time and effort in the long run. By effectively automating repetitive tasks and simplifying complex processes, you can free up valuable time and mental energy. This allows you to focus more on creative development and less on mundane, time-consuming chores, fostering innovation. Experiment with different UI elements, explore advanced functionalities, and continuously refine your tools to maximize their impact on your workflow. The more you customize, the more efficient and enjoyable your development experience will become. Thank you for watching this comprehensive guide on custom Unity editor tools. We sincerely hope this tutorial helps you significantly enhance your Unity development experience and boost your productivity to new levels.